This video starts with the title of the research, a clustering optimization indoor evacuation assessment algorithm.
Our team members consist of myself, TS Dr. Karina Irene Fariza Abu Sama as the team leader. Our team members include Amir Haikal Abdul Halim, Nur Intan Shafini Nasaruddin, Dr. Siti Fairoz Ahmad Faisal, Dr. Raiha Aminuddin, TS Dr. Nur Afidaus Zainal Abidin and Nur Afni Duraman.
As for introduction, in Malaysia, the Uniform Building Bylaw of 1984 requires every building to prepare evacuation preparedness. The researchers have created many evacuation models to help evacuation process run smoothly.
Next, this figure shows the process of choosing the best evacuation model. It starts with the requirement of UBBL that every building must have evacuation preparedness and ends with building owners applying the chosen evacuation model. However, we found that a process is missing during the decision making, the assessment for the suitable evacuation model.
Therefore, for the first invention, an indoor evacuation assessment algorithm (IIDEX) has been created which implements the K-mean algorithm. However, for further enhancement, a question has been raised. Is the K-mean clustering fully optimized to produce accurate results?
Thus, from the question, we identified two problem statements. First, due to the algorithm sensitivity to the initial clustering centers, K-mean can encounter issue when the data complexity and sample size are both high. Second, to employ K-means clustering, the user must predetermine the number of clusters, which can be challenging to do in reality.
Therefore, three objectives were made to solve the problems. Firstly, to construct an optimized clustering method in the IIAA. Secondly, to formulate the constructed algorithm by clustering the simulation result by implementing the elbow, silhouette, and V-measure score method. Lastly, to evaluate the formulated algorithm using statistical method.
For research methodology, the case study is based on the level 14 and level 13 of Yayasan Melaka buildings. Three simulation software are used to find the simulation time taken. Pathfinder, which represent agent-based model, PetGo represent cellular automata, and Analogy representing social force model.
Next, we plan the simulation studies for level 13 and level 14 to be used in the three simulation software to get the time taken results.
We started constructing the optimized clustering of the IIAA using the elbow and silhouette methods algorithm. The red square box highlights the clustering optimization. This result shows that we have achieved the first objective.
Next, the figure shows the V-measure score algorithm called in the mean algorithm. This algorithm determines which optimal cluster number the elbow and silhouette method produce the highest. This result shows that we have achieved the second objective.
Then, we developed the intra-cluster distance algorithm. This algorithm uses the highest optimal cluster number and calculates distances between data points and their corresponding parent cluster centroid. Smaller values indicate more grouping compactness.
The last algorithm is the Find Best Evacuation Model algorithm. The chosen clusters of the time taken is used to find the average time taken. The lowest average time taken between the three simulation software indicates the best evacuation model.
The data taken is distributed using a table to see the comparison. The simulation result also contains the lowest average time taken and the associated simulation software.
The pie chart shows the percentage of the lowest average time taken for each simulation. As seen, Pathfinder shows the highest percentage, 65% compared to the other two simulations.
Further analysis has been conducted using descriptive statistic tests. Pathfinder, again, has been shown to have the lowest mean value for both levels.
Furthermore, a detailed analysis was conducted to study the group statistic for independent sample tests. The standard deviation and standard error mean for Pathfinders and PetGo were used to compare the mean of both simulation models and determine whether the two population means differ.
As a result, there is no significant difference between Pathfinder and PetGo based on the independent sample test. Due to the lowest mean value, therefore ABM representing Pathfinder is the suitable and best evacuation model to be implemented for Yayasan Melaka building. This result shows that we have achieved the last objective.
For the potential commercialization, first, high-rise building owners can choose a suitable evacuation model to avoid any problems or unwanted incidents in high-rise indoor buildings. Second, occupants of high-rise buildings can evacuate using a proper guideline implemented in the suitable evacuation model. And lastly, researchers on indoor evacuation models have a specific assessment model to validate the suitable model and better understand differences of each model.
In terms of publications and copyrights, for the first idea, there are 5 publications published and 2 copyrights were registered.
We have submitted one publication for these new optimized inventions on clustering and applied a new copyright under IIDEX.
That is all for our presentation. Thank you for watching.